MASKEEI. This event supported by Aprovis Energy System. First of all, I would like to remind you regarding our participation to ensure the webinar went smoothly. First, please mute your microphone during the webinar. You can turn on your camera during the webinar, and if you have any question during the webinar, you can ask directly through the chat box. All the webinar material can be downloaded at IDPRO website after the webinar concludes. Now, I would like to welcome you, Mr. Michael Abimanyu, Executive Director of IDPRO, founder of BNOT, and also founding member of ASIOT. Mr. Michael Abimanyu is an IT and strategic business developer enthusiast. Prior founding BNOT, he was Vice President at Graha Technica Nusantara, a joint company between Mitsui & Co. and Lippo Group, providing world-class RAID 3 data center with Japanese quality standard. He is also a senior relation of Huawei Tech Indonesia prior joining the BNOT. Mr. Michael holds master degree in business administration from Prasetya Mulia Business School, and he also actively in developing ecosystem of IoT in Indonesia with ASIOT. Mr. Michael Abimanyu, the floor is yours.
Thank you, Budian. Good morning, everyone. Good morning to the speakers, to the panelists, also to the moderator, and all the participants that you already joining this webinar this morning. I would like to welcome you all to join this webinar that addressing for the efficient power supply of PIN data center. So for the welcoming, we would like to introduce to you all. I will introduce Pak Hendra Suryakusuma. He is a chairman of IDPRO, and he is a founder of IDPRO, and also he is the L3, the founder of L3 data center. So to make this coming this webinar running smoothly, so I would like to introduce you, Pak Hendra. Pak Hendra, the floor is yours.
Thank you, everyone. Good morning. Thank you for our colleagues in Aprovis, MASKEEI, and also IDPRO team for arranging this great webinar. I think this is the first webinar in Indonesia with green technology for data center industry as the main theme. Yeah, it's an honor for me to be here. Good morning, our distinguished guests. My name is Hendra Suryakusuma, and I'm the founder and currently the chairman of IDPRO. And as Pa Abi informed to you guys, in my other capacity, I'm also the founder and CEO of L3. L3 is actually focusing more in the providing cloud solution for Indonesian market. Currently, we partner with Amazon Web Service, Google Cloud Platform, Bit Super Cloud, as well as Fujitsu in providing world-class cloud solution for government institution as well as private enterprises. So let me give you a bit of background about IDPRO. So IDPRO stands for Indonesia Data Center Provider Organization. It was established back in June 22nd, 2016. Currently, we have around 10 data center providers, 3 coming up, and only 1 university, which is University of Indonesia, as our member. Currently, we manage, based on data last month, around 72 megawatts of power capacity. And this number will increase quite significantly at the end of this year. We'll go up to 120 megawatts. So this is something that we really have to consider. IDPRO also supporting Indonesian government to become the biggest digital nation in the region by collaborating not only with telco and IT providers, but also working closely with prominent leaders in supporting industry and communities. So we're working closely with Mastel and also Asosiasi Cloud Computing Indonesia. So we really focus on enhancing data center infrastructure quality in Indonesia. And in 2019, together with Ministry of Information and Communication, as well as Badan Standarisasi Nasional, we managed to roll out SNI Pusat Data. We call it 8799. So it's a Indonesia Data Center Standard. So some of the engineers are also becoming the participants for today's webinar. And in second week of this year, August this year, we will be launching two digital platforms. So IDPRO will launching two digital platform. One is for e-learning platform. So the objective is to give comprehensive knowledge about SNE self-assessment platform, so that the public will be able to compare their existing data center infrastructure with the references in SNE Pusat Data. So it's a very interesting and a very exciting years for us DC providers, especially for the past 3 years. So historically, from 2016 to 2019, compounded annual growth rate of this industry in Indonesia, based on reports from several research institutions, about 30% annually. But last year was very interesting. So due to pandemic situation, many institutions, both from public and also private sectors, are accelerating their digital transformation process. So we are lucky enough today, my mentor and also advisor for IDPRO, Pak Toto Sugiri, will be sharing more insights on this dynamic later on. He had brought DCI to a very successful IPO this year, early this year. He is the legend not only in DC industry, but also in IT industry in Indonesia in general. So if you look at the several research from many research institutions and also from IDPRO research, we conclude that there are three key main drivers of Indonesia's data center growth. One is about the macroeconomic. So fundamentally, if we look from macroeconomic perspective, Indonesia has a very solid ground. We have more than 275 million people living in this country, and 70% of them are below 40 years old. So we are a very young nation, and therefore the adoption to technology is quite fast. And that's the reason why so many technology startups are actually getting really well funded. So they enjoying significant growth because of it. Bear in mind that this internet penetration based on data from ABGI is still below 75%. So the room to grow is still very huge. And number two is digital transformation. So many institutions in Indonesia are undergoing massive digital transformation process because they need to adapt the new way of business being transacted or run. So cloud computing adoption in Indonesia is very high. We have more than 65 million of micro and small medium businesses. And many of these institutions from micro and small medium businesses are actually go directly to the cloud solution. So gone are the days where all these institutions are actually buying IT infrastructure. They're buying servers, storage. It's no longer like that. So they will go directly to buy cloud solutions. And from the government sector, we see also a lot of e-government initiatives launch, smart cities, safe province, which requires DC infrastructure as well as the internet connection also. And back in 2019, the government also launching Making Indonesia 4.0, in which it's many institutions and enterprises in Indonesia initiating and implementing IoT technology in their organizations. During the last year pandemic, due to lockdown and also working from home implementation, more and more data center and cloud computing resources needed. And that's the reason why many of the members in IDPRO told that the COVID-19 is sort of like CIO of the year in 2020. And number three is the regulation. So historically speaking, back in 2012, through our Ministry of Information and Communication, the government launched PP82, which clearly stated in section 17 clause number 2, mandating all companies that are providing public services in Indonesia, they have to have DC and DRC in Indonesia. Specifically for bank and financial service institution, our monetary authority, which is, we call it OJK, has specific regulation mandating all banks and financial institutions to have their DC and DRC in Indonesia. So looking at this dynamic and also the rapid growth in computing resource demand, which will lead to new data center being built because it's in the same ecosystem where the data center is actually in the upstream of the ecosystem. We have to find effective, efficient, green, and also sustainable way on to generate power for our DC industry. Sustainable and renewable energy is key. We know that some of the members of IDPRO already providing self-power generation using gas engine or micro turbine, and also some of them are already implementing machine learning and big data analytics in their company. That's also very important. And also finding innovative cooling technologies, which later on Professor Lee will explain more about this technology. That's essentially what I would like to share with you today. To conclude, IDPRO are willing to collaborate and to create a more secure, reliable, and green, as well as sustainable data centers in Indonesia. And through wonders of technology, I strongly believe we can achieve it and have actionable plan. Thank you so much for your kind attention. Looking forward to discuss more after the webinar. Thank you.
Now I would like to invite Mr. John Respati, Chairman of MASKEEI, Indonesia Energy Conservation and Efficiency Society. Before taking his current post at MASKEEI, Mr. John Respati has been at Clean Energy Development, long activist with Indonesian Renewable Energy Society or METU, in which he has served its board of directors. His business and professional career spans over more than 4 decades, in which he has been holding top and senior positions at various national and international companies and organizations in Indonesia and abroad. Pak John Respati attended a doctoral studies program at Virgin University Amsterdam, the Netherlands, and holds master's degree in economic and business. Pak John, the floor is yours.
Thank you, Pak Michael. Good morning to everybody. I'd like to welcome you, everybody. Welcome Pak Chandra, Pak Hendra Surya Kusuma, I'm sorry. And of course, Michael Cha himself. I would like to welcome the international panel that are going to speak and to deliver or to share their insight in this unique, I would say, this unique webinar. And I would like to thank IDPRO for giving this opportunity or having the willingness to collaborate with us, the Masyarakat Konservasi Energi and Efficiency. And I'd like to appreciate Niels, particularly in our work group for in the energy efficiency in industry, who takes this initiative to collaborate with IDPRO in presenting this webinar. And I'd like to welcome all of you. And Pak Samuel is not yet here, but I preemptively welcome him. I know I have met Pak Samuel 2 years ago, and since then we have lost contact a little bit. But we can renew our collaboration, or we can renew our relationships as of today. Well, I like to begin with saying to you that I have no intimate knowledge in understanding the technology and the business of data center. My background is on the engineering, not in engineering or IT or whatever is related to data center. But I know that we all need data center to provide the services that so that we can use our gadgets comfortably and on a 24/7 basis. I know also that the data center is of course needs enormous amount of energy to run it, to provide the services 24 hours and 7 days a week without stopping, because once the data center stops working or have problem, then everybody is going to complain all over the world. That is the fact now, today in the digitized world. Yeah, so I know once again that they need energy. That is why MASKEEI is welcoming this idea on how to and introducing the energy problem or energy challenges of the data center, in how to make it flourishing and to provide the services as good as possible. Because I know that the data center must enjoy the growth very quickly, and especially the acceleration has come in the last almost 2 years pandemic. We know that the use of internet and social media have increased tremendously, and that make us being overwhelmed by this. Yeah, I can mention that that the use of social media, use of platform, Zoom platform like this, online meetings platform like this, has been increasing tremendously, because people are sitting at home and they don't have anything to do not much to do to entertain themselves, and that as a result, now we can see the trend that people ask us to join a meeting or webinar, even in the weekend, in a Sunday and Saturday and Sunday, even at night, yeah, in the evening, I would say. Yeah, that is a sign that we are growingly, increasingly dependent on this platform, on this online platform. But unfortunately, most people perhaps do not realize that behind the convenience of using their gadgets, there is enormous amount of energy needed to run this operation. For us to communicate and get most up-to-date information for our business and social life. As I said, coffees push this use of internet platform or online platform tremendously. So we need to think about this as a challenge, how to provide the increasing amount of energy that the data centers all over the world need. Specifically in Indonesia, it's pleasant to know that Indonesia is positioning itself as an important IT country, an important internet user country. So it gives more concern about how we have to provide and to make sure that the energy is being used efficiently. As MASKEEI, as you may not know, some may not know yet about MASKEEI. MASKEEI is an CSO, a civil servant organization, in dealing with or promoting and advocating the use of energy efficiently. We are focusing on the demand side of the energy equity, as the supply side is forming in my view, like the renewable energy, for example, is providing the energy to more to conserve energy than to make it more efficient. So the use of energy efficiency, or the efforts of energy efficiency combined with the use of renewable energy, it will create, well, it will result in creating the real clean energy for all. So that is why I'm very interested in how the data centers is going to be energized, and how the energy, the data center is going to make it more green in the future. I know some time ago that the giants technology like Apple, like Microsoft, like Facebook, Twitter lately, they spend billions of dollars to make their data centers green. And this is the world trend. So Indonesia is not an exception. So we need to think about it. We need to be concerned about the energy provision for the data centers to operate. And I hope that we are going to create awareness that this data center is playing pivotal role in making the world as we know it, and in the future is going to be more enjoyable and effective. Apart from what we have to face the threat of climate change, etc., etc. But I hope that data center is going to contribute to the sustainability of these services to make the digital technology application more successful for the human endeavor. Thank you very much.
Now, I would like to invite Mr. Niels Warburg as a Chief Representative Aprovis Energy System and also Vice Chairman of Industry Working Group MASKEEI. Mr. Niels, driven by the huge potential of energy efficiency with all related positive impacts, Mr. Niels Warburg is actively promoting energy efficiency solution for the industry in Southeast Asia. As Chief Representative of Aprovis Energy System in Asia Pacific and leader of Aprovis Regional Office in Indonesia, Niels' background is heat recovery and combined heat and power in general, with a wide experience in industrial application in overall Asia Pacific. With a diploma degree in mechanical engineering from the Technical University Hamburg in Germany, Niels has more than 10 years working experience in Europe and Asia Pacific in the renewable energy sector and in medium-scale power plant application. Niels, the floor is yours.
Terima kasih banyak, Pak Maike. Thank you very much. And also from my side, a warm welcome to everybody. A good morning to the speakers and the 10 panelists that we have for today's session that we could invite and secure to give their insights. And warm welcome to all the attendees. We see big interest in this topic that we have launched for today as initial collaboration webinar, as described before, between IDPRO and MASKEEI organization. And now we are actually switching to the second part of this webinar after we got some insight and the overview about the situation in Indonesia and the situation in general. And with this panel discussion that we are entering now, we would like to address this topic more from the technical aspects. So green data center, what actually does it mean? What are the technologies that are available or that could be available in the near future regarding green data centers? To develop green data centers, one thing is to understand the problem. The next thing is then, what is the possible path? What are the options that we have so far? And therefore, we are very happy that we have 4 panelists that we have invited and that are joining today's panel discussion. So we will start with Mr. Ravindra from Agreco, who will give us insights about the resilience with greener energy in the data center business. Second, we have Louis Janicke from Johnson Controls with the title Combined Cooling, Heat and Power, a state-of-the-art solution to improve your PUE value. These are the technical aspects, followed then by Toto Sugiri from DCI Indonesia with the digital transformation in Indonesia shaping the data center landscape. Yeah, so we talk about the demand side and are very happy that we could win this famous representative and pioneer in the data center business for this webinar. And we close the panel discussion with the insights from Singapore given by Professor Lee with the title Towards Green Data Centers, Lessons Learned from Singapore's Moratorium. After the panel discussion, we have also time reserved for a Q&A session. So I urge everybody to post your questions in the chat box as indicated by the organization committee by Diane Lestari. So for the question, please use the chat box, just state your name. and also please your organization, same as the panelists that you're addressing the question to, followed by your question. Yeah, so then we will sort the questions during the webinar, and we then discuss then some questions in the Q&A session. Please be also informed that we have a spontaneous cut now in the change in the agenda. We were expecting now also the keynote speech given by Pa Samuel, the Director General from the Ministry of the Indonesian Ministry of Communication and Informatics. We were informed that he will join a bit later, so we will then put the keynote speech in between our panel discussion. Having said that, let us directly dive into the technical discussion then. And therefore, I would like to welcome and to invite Mr. Ravindra Bapat from Agreco starting the discussion. And yes?
Yeah, I'm here.
Oh, Pak Samuel joined us today, joined us already. Pak Samuel, yeah? Okay, so then if that is the case, then we can also stick to our initial schedule. Thank you very much for interrupting me and for joining us on time. Perfect scenario then. So I would like to invite then Pasemi, Director General of Application and Informatics in the Indonesian Ministry of Communication and Informatics, with a huge experience actually in this field that we are discussing today. Yeah, so we are more than happy to hear your insights, your keynote speech, to round up the big picture actually of today's discussion. And with your function as Director General, you have been active in accelerating Indonesia's agenda on digital transformation. And now I hand over to you. The floor is yours. Please go ahead.
Thank you, Niels. Good morning, everybody. But I will present my speech in Bahasa. So for you not understand the Bahasa, so you have to learn fast because the happening is going to be in Indonesia for the digital transformation. That's my excuse to deliver my speech in Bahasa. Okay. But my presentation is in English, so you can follow by reading my presentation. Oke, yang saya hormati Bapak Hendra Surya Kusuma, Ketua Indonesia Data Center Provider IDPRO, Pak Sujono Respati, Ketua Umum Masyarakat Konservasi dan Efisiensi Energi Indonesia, MASKEEI. Saya tadi lihat di screen saya ada Pak Toto, my good friends. Good morning Pak, selamat pagi. Fellow from Aprofis Energy System and National University of Singapore, also other honorable representative who cannot mention one by one, and all the participants in this webinar. Mewakili Pak Menteri Kominfo, Pak Joni G. Plate, pertama-tama saya ingin menyampaikan permohonan maaf beliau karena beliau tidak dapat menghadiri webinar hari ini. Karena pada saat yang sama masih ada dengan acara dengan Presiden. Tadinya saya juga ada di acara itu karena acara juga webinar. Namun semangat beliau untuk memacu percepatan agenda transformasi digital di Indonesia tetap ada di sini bersama kita. Ini merupakan suatu kehormatan bagi saya untuk dapat menyampaikan remark pada webinar yang sifatnya strategis. Mengingat topik yang diangkat dalam webinar ini merupakan salah satu komponen penting dalam agenda transformasi digital yang saat ini sedang kami lakukan, yaitu tentang pusat data atau data center. Tidak hanya berhenti di situ, keberadaan forum ini juga diharapkan mampu mengumpulkan poin-poin diskusi strategis tentang bagaimana tata kelola ekosistem pusat data atau data center, baik di sektor pemerintahan maupun di sektor bisnis yang bersifat green atau berkelanjutan. Oleh karena itu, izinkan saya untuk berbagi ada 3 poin utama yang terkait dengan agenda transformasi digital yang pemerintah sedang lakukan. Bagaimana kebijakan pendukungnya dan way forward yang perlu dilakukan dalam mewujudkan pembangunan green data center secara lebih luas di Indonesia. Mungkin next slide please. Jadi kalau kita lihat pandemi ini memaksa kita untuk mempercepat proses transformasi digital. Ini terbukti pada bulan Agustus tahun lalu dalam rapat kabinet Presiden Jokowi menyampaikan 5 arahan terkait percepatan agenda transformasi digital nasional. Dalam kelima arahan tersebut secara spesifik Bapak Presiden menekankan tentang percepatan integrasi pusat data nasional. Yang dimaksud nasional ini adalah pusat data pemerintahan. Seperti diketahui saat ini ada 2.700 yang dikategorikan sebagai penyimpanan data di seluruh Indonesia. Nah, ini yang kita ingin integrasikan dan ingin kita sederhanakan. Hal ini menunjukkan strategisnya peran pusat data, tidak hanya bagi sektor bisnis, melainkan juga bagi sektor pemerintahan. Mengingat Presiden sebagai pimpinan pemerintahan Indonesia sendiri sudah memandatkan akan adanya percepatan, tidak hanya untuk membangun, tapi untuk juga mengintegrasikan pastinya data-data yang ada di pemerintahan. Mandat tersebut pun kami tindak lanjuti sebagai kementerian yang berwenang di bidang digital, di mana saat ini Kementerian Kominfo sedang mengupayakan pembangunan fisik dari pusat data nasional. Ada di 4 lokasi berbeda. Nah, ini adalah kita bangun untuk menyederhanakan konsep data center yang ada di pemerintahan. Nah, data center yang dibangun pemerintah itu belum tentu cukup untuk semua data-data yang ada di pemerintahan. Ini hanya menangani data-data yang sifat strategis ataupun sifat umum yang bisa kita tangani sendiri. Namun kita juga membuka diri untuk menggunakan data center yang ada atau yang dibangun oleh private sector. Selain bentuk dukungan terhadap kebijakan data center, Satu Data Indonesia juga suatu adalah terobosan di mana nantinya data center ini adalah untuk menangani supaya data-data yang ada di pemerintahan itu bisa menjadi satu data dan bisa dipakai gunakan oleh semua instansi yang membutuhkan data-data dalam pengambilan kebijakannya. Ini juga selaras dengan program pemerintah untuk bertransformasi menuju sistem pemerintahan berbasis elektronik atau e-gov. Nah, 4 pusat data yang direncanakan akan dibangun merupakan pusat data besar yang berbasis cloud. Nantinya kita akan menyambungkan semua data center yang dimiliki pemerintah, dan ini akan menjadi cloud services, namanya government cloud. Nah, nanti di government cloud ini pun ini untuk melayani semua masyarakat yang ada, pemerintahan yang ada di Indonesia, dari baik itu timur, tengah, dan barat. Nah, ini nanti kita sambungkan, ini menjadi layanan government cloud untuk layanan-layanan pemerintahan. Pembangunan pusat data nasional juga diharapkan mampu menciptakan manfaat ekonomi yang lainnya berupa penciptaan lapangan kerja dan pengembangan kawasan ekonomi di sekitar pusat data nasional. Slide selanjutnya, sembari mengupayakan percepatan, tolong diganti slide-nya. Jadi sembari kita lagi membangun, kita juga berfokus bagaimana ada yang namanya transisinya. Saat ini kita fokus pada 2 aspek yang tidak terlepas dari pelaksanaan operasional PDN atau pusat data nasional, yaitu regulasi dan kesiapan SDM-nya. Nah, bagaimana ini kita regulasinya? Bagaimana SDM-SDM yang akan menjalankan pusat-pusat data ini atau cloud government cloud ini? Di sisi regulasi, berbicara mengenai regulasi, terdapat beberapa regulasi yang mendukung proses pembangunan pusat data Indonesia. Di antaranya, kita sudah merubah yang namanya PP 71, PP 82 menjadi PP 71. Kalau kita pelajari dengan sesama, itu adalah cikal bakal di mana kita bisa mengembangkan yang namanya transformasi digital. Salah satunya bagaimana yang namanya pembangunan pusat-pusat data. Nah, jadi itu di situ kita kasih tata kelolanya. Dalam peraturan ini telah diatur bahwa terdapat setidaknya ada 8 sektor data strategis yang harus disimpan di dalam pusat data yang terletak di wilayah Indonesia, yaitu data administrasi pemerintahan, data SDM, data kesehatan, data keuangan, data transportasi, data teknologi dan informasi, dan data pangan dan data ketahanan. Ini yang ada di PP 71. Nah, Selanjutnya adalah surat edaran. Jadi sambil kita menunggu selesainya government cloud, kita sekarang sudah memanfaatkan teknologi cloud di pemerintahan, memanfaatkan yang namanya penyediaan cloud oleh pihak ketiga, oleh private sector. Nah, untuk itu pun kita mengeluarkan surat edaran untuk memberikan pedoman bagi instansi pemerintah yang ingin menggunakan cloud. Ini ada surat edarannya, surat edaran nomor 3 tahun 2021. Apa saja yang diatur sih dalam edaran ini? Umpamanya menggunakan pusat data yang berlokasi di wilayah Indonesia. Jadi karena aturan kita, semua data yang terkait tentang pemerintahan harus ada onshore, jadi harus ada di Indonesia. Kecuali ada pengecualian, nah itu pun harus ditetapkan oleh suatu komisi. Ada komitinya untuk menetapkan apakah boleh ditaruh di luar. Kedua adalah penyedia layanan komputasi awan wajib atau cloud service wajib menyediakan fitur yang memfasilitasi kementerian atau lembaga yang dapat melakukan enkripsi. Penyediaan LK harus memiliki server untuk menyimpan data dan kunci enkripsi yang terletak di wilayah hukum Indonesia. Selanjutnya ada penyediaan LK wajib menerapkan kebijakan mekanisme perlindungan data pribadi dengan komputasi awan sebagai prosesor data pribadi. Komputasi awan juga wajib memiliki sertifikat ISO 27001. Yang berikutnya adalah ini layanan komputasi awan yang ditawarkan di pemerintah harus bisa bersifat hybrid nantinya, atau kalau pemerintah ingin membuat private cloud itu bisa, jadi dia bisa dibuatkan khusus. Nah, yang berikutnya penyediaan itu harus memastikan mereka memiliki sistem komputasi awan yang terhubungkan dengan sistem on-premise yang pusat data nasional yang tadi saya katakan. Jadi nanti akan bisa hybrid yang antara government cloud dengan pusat data yang digunakan pemerintah, pusat data private yang digunakan oleh pemerintah. Yang terakhir, penyedia layanan cloud wajib menyediakan perjanjian kerahasiaan non-disclosure. Inilah bentuk-bentuk bagaimana pemerintah itu benar-benar serius untuk bertransformasi menuju era digital. Nah, regulasi yang lain sebenarnya dengan adanya Omnibus Law ini membuka peluang bagi siapa saja yang ingin berbisnis di Indonesia. Tidak terkecuali mereka yang ingin berbisnis data center. Jadi kita lihat banyak sekali sekarang pemain-pemain besar sudah bersiap-siap atau sudah membangun, atau yang sudah punya atau yang bekerja sama dengan lokal ini sudah mulai terjadi. Nah, karena sifat perizinannya itu nanti akan dibuat sederhana mungkin. Nah, itu juga untuk data center nanti akan ada kawasan-kawasan ekonomi khusus yang bisa mendapatkan kemudahan-kemudahan berinvestasi ataupun ada insentif-insentif yang dapat diberikan. Nah, tadi itu terkait tentang regulasinya, bagaimana tentang kesiapan SDM kita. Ini juga menjadi permasalahan. Saat ini Indonesia sendiri dalam proses transformasi digital, kita membutuhkan 600.000 digital talent baru untuk menyiapkan proses transformasi. Nah, ini kita lihat masih ada kesenjangan antara tersedianya SDM dan juga kebutuhannya. Ini yang kita upayakan. Kita punya beberapa program bagaimana kita bisa memperkecil gap ini. Tapi juga diharapkan para private sector ini juga membantu pemerintah dalam mempercepat penyediaan yang namanya SDM yang ada di Indonesia, agar kita bisa juga menjadi pemain dalam proses transformasinya, bukan hanya penonton. Jadi yang melakukan nanti diharapkan juga banyak orang Indonesia. Ini kita buat pelatihan itu juga semua buat pelatihan ada digital talent kita itu untuk ASN, TNI, Polri, dan juga untuk masyarakat umum. Ini yang kita lakukan. Itu ada dua program besar, Digital Talent Scholarship, habis itu ada program Digital Leadership Academy. Ini adalah program-program C-level bentuk S2 ataupun S3, atau juga program-program khusus untuk digital leadership bagi para pejabat-pejabat Indonesia. Supaya kita pun di sektor pemerintahan ini atau sektor publik ini juga punya tenaga-tenaga ahli yang mumpuni untuk menghadapi era transformasi. Slide selanjutnya, tolong diganti slide-nya. Jadi bagaimana adalah menuju implementasi, bagaimana way forward-nya implementasi untuk menuju implementasi green data center. Kita lihat bahwa memang Indonesia memiliki sumber daya tenaga listrik ini yang banyak sekali, dari matahari, angin juga bisa, dan belum lagi banyak sekali yang namanya geothermal kita yang belum dieksplor. Ini kita harapkan nanti ke arah waktu kita membangun yang namanya data center di Indonesia sudah menggunakan energi-energi yang green. Selain tadi teknologi di data centernya pun sudah harus green, supaya tadi lebih hemat listrik, lebih friendly environment-nya, itu yang kita harapkan. Kalau kita lihat dari ketersediaan energi terbarukan cukup besar di Indonesia, ada 417,8 gigawatt. Nah, ini yang belum banyak diekspor. Saat ini yang sudah diekspor itu baru 17,9 gigawatt panas bumi atau geothermal. Bioenergi juga kita sudah mulai menggunakan, ada 23,9 menggunakan bioenergi. Nah, untuk angin mamanya ada 60,6. Air juga kita sudah banyak sekali, ada 75. Nah, surya ini mulai berkembang, solar panel ini mulai berkembang, sudah ada 207 gigawatt pusat tenaga listrik surya ini. Nah, potensi ini juga mendorong banyak pelaku bisnis cloud seperti Microsoft, Alibaba, Google yang berinvestasi untuk membangun pusat datanya untuk Indonesia, dan kita harapkan mereka pada saat membangunnya ini sudah menggunakan energi-energi yang green. Nah, kita juga lagi membuka pusat-pusat kawasan untuk pembangunan data center. Salah satunya yang baru saja ditetapkan adalah Nongsa. Ini juga bisa dimanfaatkan, dan kita akan coba sediakan energi green-nya di sana. Kendati saat ini kami masih berfokus pada penyediaan data center pemerintah yang sesuai dengan SNI, namun kami sangat terbuka terhadap ide-ide ataupun peluang pengembangan kebijakan green data center yang dapat diinisiasi oleh para asosiasi untuk mewujudkan visi sebagai data center hub di kawasan. Jadi Indonesia itu semenjak ditantanganinya PP 71 atau GR 71, kita sebenarnya sudah menerapkan suatu strategi. Indonesia ingin menjadi hub untuk pembangunan data center di kawasan. Kenapa kita mau menuju ke sana? Karena kita tahu bahwa kita punya energi yang cukup untuk melayani data center yang akan dibangun. Karena kalau kita bicara data center, pasti kita bicara kesediaan energinya. Itu kira-kira yang bisa saya sampaikan pada hari ini. Terima kasih. Mudah-mudahan acara ini bisa menyumbangkan ide-ide kepada pemerintah juga dalam membuatkan kebijakan, bagaimana arah kebijakan ke depannya terhadap data center yang akan dibangun di Indonesia. Sekali lagi, terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih banyak Pak Direktur Jenderal Samuel. Kami sangat menghormati waktunya Pak Samuel untuk ikut webinar ini, untuk sampaikan hal-hal dan visi dari pemerintah Indonesia. So really our thanks, and we are appreciating your time that you have joined us and given this insight. Since we have audience also from abroad, we have quite an international mix of attendees for this webinar today. Let me just in brief point out some bullet points that I have seen in your presentation to summarize in very brief. However, also for all participants and attendees that have joined now, as informed before, we will upload all the material on the homepage of IDPRO. The link will be shared with you by email after this session. Also, the material will be available after the session. So also this presentation material can be downloaded afterwards. To summarize in brief, I've seen the Indonesian government understands the issue and the need of the hour to push with several regulations and letters it just newly issued, the topic of data centers in general, but also the aspects of green data centers. And especially on the last slide, I have read and heard by your words that standardization of green data centers is one aspect that the Indonesian government is also considering, same as incentives for sure are also important aspects for the business itself, for the private sector, if then going to develop green data centers. So it's very useful then to have this outline, yeah, by the Indonesian government, given now by you. So with this overall picture, with the overview that we got with this keynote speech and introductions before, let us now dive into the technical aspects. As introduced before, we are starting now the panel discussion of today's session. And therefore, I warmly welcome Mr. Ravindra Bapat from AGRECO, joining us today from India. Mr. Ravindra, a warm welcome to you. So Mr. Ravindra has long-term experience, more than 25 years in the data center business, so provided or supported by many certifications from data center aspects, and the data center expert for Asia Pacific within AGRECO company, AGRECO organization. I think that shall be sufficient for the introduction. Mr. Ravindra, I hand over to you.
Selamat pagi Indonesia. Can we have the slides, please? Okay. Thank you, IDPRO. Thank you, MASKEEI, and thank you, Aprovis, for giving me this opportunity to talk about the greener energy for data centers and the speech which was given just now by Director General in terms of various policies of Indonesian government and how it is incentivizing, or there are various policies for the greener data centers. I'm really glad to have that. And I think my session will throw some light about how to make data centers green in terms of the power perspective. There are various ways in terms of making the data center green, but today I'm going to discuss more from the power perspective. Yeah, next slide, please. So this is a brief agenda for next 10 to 12 minutes, what I'm going to talk about. What is the growth story we have heard from Indra, we have heard from all the speakers before that, how it is growing. Now, when we talk about data center, obviously data centers are power hungry. We just saw in the previous presentation, we are talking about almost 3% of the global power is being consumed by data center, and is further going to grow up. So when it comes to the power hungry data centers, what it is looking for is good amount of power. How a grid is able to support that, or what could be the considerations for getting that particular power. How do we make sure that the solutions, whatever are there, which are green, how we integrate with the existing solutions? What are the core benefits of having these particular solutions? And we'll talk about one case study where we have deployed a similar application for a data center, and a brief note about my company, AGRECO. Next slide, please. Okay, so probably Park Kendra has talked about 30%. I am not talking about 30% CAGR, but yes, I think it is growing at a dramatic pace, and the 5G is being rolled out, and there is further demand in terms of users. And Indonesia, like I heard from Indra, it's talking about almost 70% population, which is below the age of 40, which is more and more IT savvy, and they're using more data. Obviously, with 275 billion population, the user is the major driver. So for data centers, data is at the center of the data centers. That means the people who are consuming, the people who are using data are going to create more and more storage, more and more applications, more and more games and e-commerce and whatnot. So it is all driving the growth of data centers. It is also the rising middle class, the tech startup scenes, whatever we are seeing, it is all talking about growing data. We are talking about MSME sector, which is also growing, and which is talking about using cloud platforms directly to make sure that, I mean, obviously there is more the growth in terms of the data centers. Also, the local regulations which ask for keeping the financial data. We just saw in the previous presentation how government is talking about empowering and making sure that all the services for the people are being available. So there is more and more data which is being generated and being processed and being stored. So obviously there is a huge growth in terms of data center, and probably I will change my numbers to 30% next time in my next presentation, Pakenda. Yeah, next slide, please. Yeah. So with this IT massive demand which is coming in, because we see that this is driving, the pandemic has further fueled the growth of data and the data centers. Now, whether the question is whether the grid can keep up with this particular rising demand, because earlier we were talking about 2 megawatt, 3 megawatt kind of phase one scenario, but now we are talking about 10 megawatt, 15 megawatt as a startup, and we are looking at 100, 150 megawatt data centers at each location. And this is something in reality. It is not something which is on paper, but people are planning, and people, the cloud guys are talking about 100, 150 megawatt data centers at one location, and there are multiples of it. Okay, so when such a huge amount of data which is going to come in because of the data centers, obviously the IT loads are going to go up, and whether the question is whether grid can keep up with this particular demand. Okay, so in line with the requirement or in line with the speed with which the players are growing. Next slide, please. Okay, now for data center, resilience is the important factor, because everything talks about, we know that it has to be up and running all 24/7, 365 days. There cannot be a downtime for any reason whatsoever, whether it is a natural issues or whether it is a human created or whatever it may be. You cannot go down. Okay, so there has to be resilience when it comes to the grid power, because power is something which has to be made available all. So there has to be resiliency in the power. The last mile connectivity is also important. That means where your location of data center is, you need the power over there. So the last mile connectivity is important. And of course, what kind of fuel source on which the power is being generated and what you're consuming. So that's also another important consideration when you are looking at the power for the data center. Next slide, please. Okay. So grid connectivity and stability, if you look at the challenges and some of the answers which are also there. So if you look at the grid connectivity and stability, because as I said, the data center has to be up and running. It has to have that enough amount of power. It has to be in good quality power, which has to be which is required from the grid, and also it requires the connectivity to the last point. So that's one of the important aspects. The second is the infrastructure. Okay, now if we have got a substation from where the feed has been given, whether that substation can be upgraded quickly to give that additional power, or whether it can cater that additional demand. Now, if this infrastructure need to be changed, how fast it can be implemented, whether there is a space available, whether there is additional transmission line required, or whether there is additional GIS or substation which has to be created. All those things have to be seen from the current infrastructure for the grid. What are the ratio of renewable to fossil fuels which is there, because we are talking about the greener energy, and we are talking about greener data center, which means it has to have renewables into it. So what is the ratio of that, and whether this integration of renewables along with fossil fuel, whether it is possible, how it can be done. Okay, that is also something which needs to be seen. Climate change is one of the major factor we have seen in, countries like US and Texas, where the power went down. You can imagine, the climate is currently playing havoc. We have seen floods, and we have seen natural calamities happening across the world. It has grown exponentially, and this is something which will definitely going to impact the grid, because obviously the thunderstorms or the flooding and all these things will cause for a outage of power. Okay, so there are all these climate conditions will also affect the grid supply, which is very important for data center to run. Now your data center cannot go down because of any of the issues which are being faced in the outside world. It has to be up and running all the time. So we need to see that this is challenge, how it can be addressed. Next slide, please. So when we look at these challenges, we are looking at a solution which can be implemented at speed, because you have to meet up with the growing demand for the hyperscalers. How you can scale it up, that's also important, because today we are talking about one data hall. Maybe by the time you finish that, the second data hall, there is a demand, and how quickly you can scale your power. Obviously, it has to be the cost of economies have to be seen, because it ultimately drives down to the cost, and at the same time how green it is in terms of the power generation. So that's also something which had to be seen. Next slide, please. Okay. So what we are talking here is a hybrid solution, which is combination of a solar, a gas, and a battery storage. Okay, and solar can be completely modular. So rather, all our solutions are completely modular. So uh, you can add up, or you can increase the power, or you can reduce it as based on your requirement. You have supported by that. I mean, the main power generation can be gas, which can use any of the fuels, whether it is LPG or CNG, LNG, whichever the form of gas it can use. It's a 24/7, and because it is generated at site, you are isolating yourself from the outside world in terms of the natural calamities and all the stuff. So you are generating your power at site. You have more control on your own power. It is also having the battery storage as a part of it, so that takes care of as a spinning reserve, and it also can take care during the night time when the solar is not available, so it can act as a solar. And if you look at the feature, it's zero capex commitment, because our entire model is on a leasing model, so we are not asking customers to invest heavily into this. Okay, so it's a zero capex commitment, and it's easy to scale up. If you can see the modules, it is all in the modular structure, so you can add the modules, you can reduce the modules depending on where your requirement. You don't have to go for a 30 megawatt, 50 megawatt from the day one. You can scale up as small as 1 megawatt, 2 megawatt, depending on how your expansion business expands. Okay, so it's a completely modular and a scalable solution that Agrico provides, and because it's zero capex, you don't worry about it. We will operate it, we will run it for you. We just paid for the usage, and once you have the grid, we call this also as a intermediate solution or a bridging power. Till the time you get a grid, we can deploy this and we can run it till the time you want it. Next slide, please. Okay. Since we are talking about energy efficient solution, we can also recover the heat from the waste heat from the gas engines, and we can use it for converting into the cooling. That means the chilled water, which is another major component required for the data center. We can generate the chilled water out of the heat which is being generated from running the gas engine. So that way you are actually making it much more green, because you are taking away the heat and then converting into the cooling. So your requirement for the electric chiller will also go down drastically in the solution what we are talking about. Next slide, please. Okay. We look at some of the data and the statistics which is available. I've given the links below. Now, if we currently the grid in Indonesia is heavily onto the coal, and that's why you will see a carbon emission. If you see that factor of 0.76, that's a 7.76 tons of CO2 per megawatt of power. That's the carbon emission when you are consuming the power from the grid. Okay, now we have just done a rough calculation. Say if it is a 7 megawatt of data center, how much it will be emitting the carbon dioxide if it is running on grid, which will be equivalent to 156,000 tons of CO2 per year. Vis-a-vis, if you go in for a natural gas solution, what we are talking about, what we have presented, it will be generating CO2 worth 107 tons. Okay, so there is a saving of almost 31% as compared to the grid. So you are actually making it much more greener for your data center by reducing your carbon footprint to a great extent. And if you combine it with the absorption chiller, you will further reduce it to 42%. So you are actually saving a 42% of the CO2 when you are using this particular solution. So there is a huge impact in terms of the carbon emissions when you are using this particular solution of using gas generators with the absorption chiller at for your data center power generation. Right. So this is the impact, and I think this will be loved by all the hyperscalers which are coming to India. The names, big names, Microsoft, Google, and whatever you just seen coming to Indonesia. They have got a mandate that they want to go net zero, and they are actually looking at solutions which will reduce their carbon footprint, whether it is their own data centers or whether they're their colo players or the partners. So I think this is a solution which will be, and from the previous presentation from the Director General, where you're looking at incentivizing data center players for making the greener energy, I think this will be a solution to look at. Next slide, please. This is another solution, which is a flexible mobile solar. So you've got a big 30-acre, 40-acre land for your data center on day one. You're not building everything on day one. You're starting in a modular manner. So the remaining area, so if you're consuming say 2 to 3 acres for construction of your phase one of your data center, the balance area can be utilized for putting up this flexible and mobile solar plants, which doesn't require any civil foundation. And within a week, 10 days time, we can put up this entire plant and we can roll it back. And again, it's a leasing model, so you don't not paying for the capex as and when it is required. So till the time you have the land available, we can use it to generate the renewable energy at source, at where you are going to consume it. So this is another solution from Agrigo, which can help you in making your data center green. Next slide, please.
Mr. Ravindra, please 2 more minutes to go.
Sure, I'll connect it. Yeah, so this I talked about in terms of the benefits for the, and I would just like to quickly go to the next slide where we have actually done it for data center. Okay, so far it's not a theory, but it is actually done in practice. If you can go to the next slide, please. Yeah, so we are actually running a data center while we are speaking for last more than 1.5 to 2 years now in Dublin for a large colo player in Ireland, because they were also having the same challenge of not getting the grid power. So that's where we have deployed this solution in just 12 to 14 weeks time. And you can see it's entirely modular stuff. We are running it. Entire thing is being maintained by Agrigo. It's a 14 megawatt of power, which we are supplying to the data center. And this is the prime power for data center. There is no grid power. This is the prime power with 24/7 entire site support, everything being done by Agrigo. So we have done it in Europe. We have done it in Dublin. We are already talking to a couple of customers in Europe and in Indonesia. So this is a solution which we would like to offer. Next slide, please. Yeah, this is our global footprint. I will specifically touch upon Indonesia. Next slide. Agrico is into a lot of other stuff where we are a global leader in temporary power and cooling and testing. We help data center customers in terms of providing power or cooling and help them in terms of testing the data centers for whether it is UPS generators or the heat load for the data centers. So there are a variety of solutions when it comes to power and cooling and testing. Next slide, please. So we are in Indonesia. We are local. We are locally available to you, and we have deployed more than 1,000 megawatt till date in Indonesia. So we have that background. We have an experience of working in Indonesia and running the power plants for PLN and for other companies as well. So this is our credentials. So we have that experience, and we can definitely work for your data center application as well. Next slide, please. So you can reach out to me, my colleague who is based out of Jakarta. His name is Indra. Park Indra is also there. You can reach out to any of us, and we'll be happy to help you in whichever way to make your data centers green in terms of power or cooling or in terms of testing. So please do let us know, and we'll be surely able to support you. We have also got a white paper. Can you go to the next slide? This is my second last slide. So
No.
yeah, so you can, this is the white paper. You can get more details from it. You can scan the QR code and you will be able to download it. Okay, so you can, there is a lot of information about the solution and how to go about it. A lot more is available. So make use of it. Whenever you require it, you can reach out to us. As I said, I will be happy to help you. Thank you.
Thank you very much, Mr. Ravindra, for your insights and a really good start there to see also the focus for green data center. We saw the questions coming up already. Yeah, how to define a green data center. So for sure, we talk about carbon emissions. And in that aspect, I would like to welcome our next panelist, Mr. Luis Janicke from Johnson Controls, because he will elaborate even more into that direction. So Luis, with also long-term experience in the heat recovery business, in the energy business, will now give us insights about combined cooling, heat and power, a state-of-the-art solution to improve the PUE value. So even more in focus on what we have seen and presented by Mr. Ravindra already. Therefore, I would like to welcome Luis and hand it over to you. Please, the floor is yours.
Thank you, Niels. Good morning, and thank you for giving me the opportunity to participate in this webinar. My presentation is going to be around combined cooling, heat, and power. Essentially, for data center, it will be power and cooling, since this is the major demands of data center. And we call it a state-of-the-art solution to improve the PUE value, the power usage effectiveness of the data center. Although cogeneration or combined cooling and power might be a new technology in data center, it is actually a proven and mature technology in other industries, like, for example, district cooling, or many airports indeed implement cogeneration with power and cooling for the terminals. In Southeast Asia, for example, Johnson Controls has experience in Kuala Lumpur Airport, Bangkok Airport. So cogeneration and combined power and cooling might be a new idea in data center, but definitely is not nothing new in the industry. Next slide, please. So I'm going to start with a very quick introduction about Johnson Controls, who we are. We are a global multi-industry company with more than 100,000 employees, more than 135 years of experience, and we have presence in the major economies and countries, more than 150. Of course, we have presence in Indonesia, and our main office is in Jakarta. So if you want to reach us locally in Indonesia, our colleagues from Jakarta office I will be very happy to serve you. Next slide, please. There are many brands under the Johnson Control portfolio. Today, I'm going to focus on, as I said, power and cooling. So regarding cooling, chiller brands, we are a large chiller OEM. So I would say York and Hitachi probably are the most relevant brands around the cooling processes as a chiller for data center. But you can see there are many other brands for other industries. Next slide, please. So just to mention regarding the data center vertical within Johnson Controls, although today we are going to focus on cogeneration and combined power and cooling, we have presence in the data center industry with HVAC, so also crack units or air-handled units, building management, controls, fire, security, and of course, we serve all our products and solutions into the data center vertical. So if anyone is interested in other parts of data center solution that JCI can provide, Johnson Controls can provide, of course, you can reach us to us. Next slide, please. So let's focus on the topic of today. As they mentioned before, data centers are power hungry. They are large consumers of power, and also, especially in Southeast Asia, cooling. Data centers today estimate to consume around 200 terawatt hour of power every year. And totally information and communication technology accounts for 2% of global emissions. But actually this consumption is increasing very fast. Roughly every 4 years, the consumption of data center in terms of power doubles. And by 2030, around 20% of global electricity demand will go for ICT or information and communication technology, where data center play a very important role. So definitely more efficient and greener data centers are needed in order to reduce the carbon footprint. Data centers are not different for any other industry. We are moving into decarbonization, into a net carbon neutral economy. And similarly to many other industries, data centers have to move in that direction as well. Next slide, please. So for those who are not very familiar with CCHP or cogeneration, basically combined cooling, heating, and power integrates the production of usable heat and power, electricity in one single highly efficient process. So if we get the power from the grid, like in a traditional data center design, this power that is given by the grid is coming from power plants that are located around the country. And in Indonesia, roughly the generation of the electricity in power plants, we can say is around 45%. Moreover, this power mostly comes from coal power plant or fossil fuel power plants. So the electricity that comes to the grid is not that highly efficient produced, and also a large amount of that electricity is actually coming from fossil fuel power plants. Now, if we move into cogeneration, you can see at the bottom of the slide, efficiencies are above 80%. And why is that? In a cogeneration plant, we are using the same power generation equipment that you can find in a power plant. For example, it could be a gas engine, or it could be a gas turbine, fuel cell, but all the heat that is generated by this power generation equipment is not released to the ambient, it's not lost into the ambient, it is recovered by heat recovery equipment. And all this heat is sent to absorption chillers that actually converting the heat into the cooling that is needed by the data center. I'm still fascinated how this absorption chiller can transform heating into cooling. But they do so, and therefore is a perfect match for the data center, which they are power hungry, but also cooling hungry. So it's a perfect match to do cogeneration at site, produce your own electricity at a more efficient rate, cleaner, but also use all this heat available to produce the cooling demand on the data center. Next slide, please. So why absorption chillers is a good match for cogeneration? Essentially, and this is the most important thing, because absorption chillers are driven by waste heat. So if I'm replacing my mechanical chillers in a traditional data center design for absorption chillers, I am no longer consuming most of the electricity that will go to the chiller plant within the data center. And I'm recovering all this heat that otherwise will be released or not used. Also, very important point of absorption chillers is the refrigerant they use. If we look again at a traditional data center design where they have mechanical chillers, normally these chillers are using HFCs or HFO refrigerant that do contribute to global warming when these are released to the ambient. But absorption chillers are using water as refrigerant. It's one of the few natural refrigerants in the market, together with ammonia or some hydrocarbons. Of course, absorption chillers will reduce drastically the power consumed by the chiller plant in a data center, and this power saving comes with the savings in CO2 emissions. Of course, if I'm not consuming that amount of power, I'm not releasing all that CO2 equivalent to the generation of that power. And also absorption chiller is they produce the cooling with a chemical process. So there is no compressor inside. This is replaced by a few pumps, small pumps. So it's also a very quiet and vibration-free piece of equipment compared with mechanical or more traditional chillers. Next slide, please. So within Johnson Controls absorption chiller portfolio, there is a huge flexibility of heat sources and temperatures. So we actually can adapt these absorption chillers to the power generation equipment. If we are using gas engines or gas turbines, we can have direct exhaust absorption chillers. We can also drive this absorption chiller with steam. For example, in case of large gas turbine that have HRSG or steam boiler. We can also drive absorption chiller with low temperature hot water at around 75, 80 degrees. So very low temperature hot water can be also recovered to produce cooling in absorption chiller. And very interestingly, we can also combine the different heat sources in the absorption chiller. So we can have a single chiller that takes exhaust gas plus hot water, or steam plus hot water. And that definitely simplify the design, minimize the number of chillers and the footprint of the cogeneration plant. So in a typical scenario with a gas engine, for example, where you have energy coming out from the exhaust gas, and you also have a lot of energy coming out from the jacket water, you can have a one-to-one configuration, one engine, one chiller. The chiller can take exhaust gas plus hot water, or steam plus hot water coming out from the engine. In case of fuel cells, for example, also we can take the exhaust from the fuel cells, or the hot water in case of some fuel cells are supplying hot water as a byproduct. So as a summary, very large portfolio of absorption chiller able to fit any kind of power generation equipment in a cogeneration plant. Next slide, please. So I just want to give you a very simplistic comparison between a traditional data center design and how this same data center will look like if we apply cogeneration or combine power and cooling. So in this case, we can say that this is an existing data center, for example, and the IT load of this data center is 1,200 kilowatt or 1.2 megawatt. There will be some loads associated with the UPS or auxiliary lighting. So roughly around 1.4 megawatt is going to the IT load and the auxiliaries. But you can see a big amount of energy of this data center, of a traditional data center, is actually going to the chiller plant, especially in this part of the world, Southeast Asia or Indonesia, where things like free cooling or milder climates are not available that actually impact on the PUE, of course. So 600 kilowatts of this data center consumption is actually going to the chiller plant. Chiller plant essentially consists of the mechanical chiller, heat rejection equipment like a cooling tower, and then some pumping groups like chill water pumps and cooling water pumps. But the majority of the consumption is concentrated in the mechanical chiller, in the compressors. And if we see in percentage, roughly around 30% of the total data center consumption is going to the chiller plant. So therefore, for 1.2 megawatt IT load, I will need to import 2 megawatts of power from the grid, okay? And I said before, this power from the grid in Indonesia roughly comes with an efficiency of about 45%, but also the CO2 emissions related to this power are quite high, since most of this generation are coming from coal power plants, or natural gas and some other fossil fuel power plants. Now, if we compare this with a cogeneration plant, we'll see the difference. Next slide, please. Okay, so if we change the design with a cogen power and cooling production at site, then I'm not changing anything related with the servers or the ITs. Still, I'm having 1.2 megawatt of IT load. My auxiliaries, UPS, lighting, etc., will remain the same. So 1.4 megawatts are still going for the same data center. What I'm essentially changing is where do I get the power? In this case, from a gas engine generator, it could be gas turbine, or it could be a fuel cell. But in this example, I'm using a gas engine, and essentially I'm replacing the chiller plant by using an absorption chiller plant. Heat rejection equipment and pumps are still there. It's still a chiller plant. So around 100 kilowatts or even below will still be part of the chiller plant electrical consumption. But in this case, it's no longer 30%. We are talking around 7% of the overall consumption of the data center will go for the chiller plant. So between the 1.4 megawatt of the IT load plus 100 kilowatt of the chiller plant, I need to provide 1.5 megawatts of electricity to this data center. Remember, in the previous scenario, we were importing 2 megawatts from the grid. Now I need to produce at site 1.5. So there is a half a megawatt or 500 kilowatt reduction in power to this data center. And of course, that has a huge impact on the PUE, the power use effectiveness of the power of the data center. Previous value was 1.67, and with a cogeneration or combined power and cooling, my PUE value drops to 1.25. Now, this 1.5 megawatt of power will be produced by the gas engine, that it will be releasing a lot of energy in terms of exhaust gas and jacket water. All that heat is going to be recovered in the heat recovery equipment, and it will be sent to the absorption chillers that will transform this heating, this thermal energy, into the cooling capacity required by the data center. Roughly for a 1.5 megawatt engine, the absorption chillers can produce, or there is enough heat in the engines to produce around 1.5 to 1.7 megawatts of cooling, which is roughly enough to feed the data center cooling needs. So there is huge savings in electricity. If we consider 8,000 hours a year, roughly 4,000 megawatt hour of electricity, it is saved a year. And that accounts in this example for more than 3,000 tons of CO2. The CO2 emissions can drop compared with a traditional design by more than 40%, as Ravindra was mentioning before, not just because I'm saving a lot of power, also because the emissions of a gas engine generator are lower than the average emissions of the power imported from the grid. So it's a very powerful solution, cogeneration for data center, to improve the PUE and reduce the CO2 emissions associated with this demand in power and cooling. Next slide, please. Of course, ultimately, the goal is to get 100% green data center. They were mentioning before also today, there is very large data center developments around 100 megawatt or even bigger than that. Today, only around 80% of power in Indonesia is coming from renewable resource. There is a huge potential, but today is not that high for the moment. So getting these very large data centers, 100 megawatt or 50 megawatt, large capacities, might be challenging to get all that power from renewable energy. So always it would be a very good solution to improve the efficiency of the data center, which is essentially reducing the PUE. As I mentioned before, by using cogeneration, the CO2 emissions can be reduced by more than 40%. So it's a huge impact on the carbon footprint of data center when using cogeneration, since the efficiencies of the cogeneration goes above 85, 90% compared with the average value of electricity generated in the grid of 45%. But also in future, also this power generation equipment, gas engine, gas turbine, fuel cells can be fueled by renewable fuels like biogas or even green hydrogen. So it is also possible to achieve the green data center with the cogeneration concept if renewable fuels are available. So very powerful tool, as I said before, for improving the efficiency and reducing the CO2 emissions in data centers. Next slide, please. Okay, so if you have any questions, you can drop it in the chat box. You can contact me or my colleagues in Indonesia. Thank you so much. Terima kasih. Over to you, Niels.
Thank you, Luis, for this insights and also the detailed calculation as an example that we have seen now. The questions are actually coming up already. Yeah, so let us directly go to the next panelist so that we have some time to discuss some questions also at the end. Therefore, I am heartily inviting Pak Toto Sugiri, now giving the point of view as a founder of the data center, the DCI data center in Indonesia. So for sure, a legend in Indonesia, if not only in Indonesia, maybe also in other countries. I learned Pak Toto studied computer engineering in Germany, my home country, in a time when Germany was still divided and punch cards were used to program computers. So Pak Toto, the floor is yours, and I'm really looking forward to your insights. Silakan.
Well, thank you, Neil. So I didn't prepare any presentation because, but this is I'm going to talk about the data center market and the movement in Indonesia in terms of the energy efficiency and all the constraint of what we have over here, constraint or the challenge. Yeah. So as it was mentioned by Hendra in the initial speech, Indonesia will be growing very fast in terms of data center for sure. We have experienced this in the past 4 years. We grow more than 60% almost every year in terms of capacity. So the challenge what we have here for sure related to the green data center is how do we get the supply of the renewable energy into our data center. As we know, those source of renewable energy that was mentioned, Pak Semi, most of them are located in other area across Indonesia. And the challenge will be going back to PLN. How do they transmit those power to Jakarta, where the center of the data center in the country, it will be in Jakarta and surrounding. So that will be a big homework for PLN, which is currently supplying the data center, the electricity in the country. So that is one thing on the renewable energy. So the other challenge will be like on how efficient are we going? What we are currently working, how efficient are we going to use the power? What we're currently doing can do is for sure the direction is correct, like our colleagues have presented. So how do we minimize the power loss, and how do we make more efficient in the cooling side? That is one thing. And then we are also observing the evolution of the microchips, but I think in the next 5 to 10 years, we will be seeing more efficient microchips that use less energy. That is one thing. But if we do the simple math on calculations, those efficiency gained by those new microchip technology will be like around half of the growth of the power needs or the computing needs on the data center. So like if Intel has reduced the power needs for the data center products by until now by 10% only. It's so they fall short about 25% improvement in energy efficiency. And we are still waiting for the so-called ARM architecture. The ARM architecture is like the advanced race machine, but I think Google start to move into that. But it will take time until those big providers are migrating into the more efficient technology into it. So the second thing we will see also effort on that area, that chips are developed to be able to work at a higher temperature. That is also a good news. I think Microsoft is working on it, so that will reduce the cooling requirement. But in all in all, this I believe this will take around 5 to 10 years from now. But we are competing with the growth, the needs of growth itself. So the second thing, yes, based on our experience, we are serving some of the hyperscaler, the cloud providers, the content providers here in the country. They demand a low PUE for sure. This is that because this electricity is one of the biggest costs of on looking to their size. While the retail market there still has smaller, lower awareness of the power efficiency. So that's what we can share from the angle of the market. I mean, from how much potential do we see in lowering the energy consumption on data center by using the automation, the intelligent management of data center? That is a lot, actually. I agree with that. How do we reduce the waste of energy, especially on the cooling area, where if we consider in total in the industry is more than about half of the power is used for cooling. So that is an area where we are working on it now, on how do we reduce our cooling costs by implementing a lot of automation, placing a lot of sensor and studying the dynamic cooling, the heat generation, and then adjusting our cooling capacity into that. So that's in a nutshell that I can share. I guess I believe also that Indonesia has a big potential to become a nation with the green energy, considering we have a lot of space, we have a lot of renewable energy resources. But then I think that the government needs more coordination between to reach that goal. Coordination with the PLN and everybody that is aligning on the same goal.
Okay.
That's all I can share, Neil.
Yeah, vielen Dank, Pak Toto. Thank you very much for these insights. And for now, what I captured from your insights, from your point of view, yeah, that is indeed very interesting to complete the picture. How much potential do you see in future developments, but like near future developments? Yeah, so to say, what is a combination when we discuss about green data centers and the technologies to become a green data center? We see there are several options. And we have learned about state-of-the-art technologies, which are simply available in the market, but we also, for sure, hear and read and see more technologies that are maybe in the near future available. Yeah, and in the end, it will be a combination. I'm pretty sure a combination renewable energy to reduce the carbon footprint, combined for sure with the energy efficiency measures. Yeah, so we are not talking about competing technologies, but as I understand from your point of view, it's a combination of all together. Yeah, and That is
Yeah, correct. It's a combination of both. We have to do while waiting for the renewable energy. We have to do the other technology in getting ourselves more efficient.
yeah. Thank you very much again for these insights. And then we are jumping directly to our fourth panelist for today. Now I welcome Associate Professor Lee from Singapore, National University Singapore, who is there in the Department of Mechanical Engineering, dedicated to the energy questions in general. And as I learned, with a clear focus on energy efficiency, cooling, air conditioning. So indeed the background that we need for these applications here. And having said that, I hand over to Professor Lee. The floor is yours. Please go ahead. Professor Lee, are you there? We don't hear your voice yet.
Okay, can you hear me now?
Yes, now we
Yeah,
can hear you clearly. Okay.
So sorry, I forgot to unmute myself. Yeah. Okay, so I think just now I was basically saying the title of my presentation. It's actually towards green data centers, lesson learned from Singapore moratorium. Okay, so I'm actually the executive director of Energy Studies Institute, but I also direct our Center for Energy Research and Technology, as well as the Cooling Energy Science and Technology Singapore. So I think why I'm actually highlighting this is because moving forward, we see the need to bring together policy studies together with technology development in order to accelerate the adoptions of innovative and sustainable solutions for various applications, including data center. Okay, first I'd like to just show this particular slide, which actually highlight the strong demand and growth of data center across the APEC region. But if you actually zoom into the Southeast Asia, right, yes, you can see that the compound annual growth rate is in fact the highest, right, at close to 13%. And the market size in 2024 is projected to be $3.5 billion. So there are a couple of reasons of why the region actually expected to experience a highest growth. So due to reasons associated with the rapid pace of digitization, which is kind of accelerated due to the COVID, right? So a lot of us are actually working from home, learning from home, right? As well as other demand for the cloud-based services, 5G, Industry 4.0, artificial intelligence, as well as IoT. Yeah. So that's why I think this region is actually expected to see a very vibrant growth in terms of the activities related to data center. But what about Singapore? So where does Singapore stand in the global data center market, right? So I'll just quickly show this particular slides. So Singapore is actually the top, among the top ideal markets for data centers across the globe, and actually holds half of Southeast Asia data center capacity, right? So I think based on the various report, right, Singapore actually ranked either the second most attractive city to build data center, or according to the Cushman and Wakefield 2020 Global Data Center Market comparison, Singapore is ranked the 5th out of 48 markets. So there are a couple of reasons why Singapore is actually attractive as a data center hosting location, right? So this includes like it being a major APEC hub for submarine cables, and the market existing presence, a dense fiber network array of available services, as well as well-educated workforce and a stable government. So if you look at the cost of construction for data center, actually Singapore is actually pretty attractive, right? So it's actually lower compared to some of the other global data center markets. But associated with data center, the presence and operations, that's the associated carbon emission, right? So if you refer to the report by IEA, International Energy Agency, so data center is really accounting for the 200 terawatt hour per year in energy consumption, which is about 1% of the total electricity demand worldwide. So associated with that is obviously the very significant CO2 emissions, right? Because most of the electricity power generation is still done using fossil fuel, right? So that's why there's this associated CO2 emissions, which obviously we need to sort of address on the quite urgent basis. So closer at home, right? So there have been a lot of discussion. So how do we achieve enhance the sustainability of the Singapore data center industry? So if you look at the current situation, so we have about 60 data centers here in Singapore, according to a tally by research firm Structure Research. And the industry is expected to grow about 5% annually until 2024. Okay, but data center is actually an intensive user of electricity and water, right? I think like our neighbors in Southeast Asia, we all experience a hot and humid climatic conditions, right? So that actually translates to a large amount of energy just for sort of powering your cooling system, right? And you look at Singapore, currently our data center industry is accounting for 7% of our domestic electricity consumption in 2020. And in fact, that's actually so much higher compared to other so-called leading DC markets, right? So I think that's why there's this urgent need to sort of look into the development of a sustainable solution, right, in order to enhance sustainability as well as to reduce the CO2 emission for our data center industry. So for Singapore, in terms of our electricity generation, right, it's actually primarily based on natural gas. You see, well, it's actually the cleanest form of fossil fuel, right? It still generates the CO2 emission. So that's why there's really a need to sort of adopt a collaborative approach, right, in order to more holistically enhance the sustainability of our DC industry. And you might have read that currently there's a moratorium being imposed on new data centers in Singapore, right? And in 2019, this was actually put in place due to concern over the industry carbon footprint. And according to data center dynamics, the moratorium could last until 2021, which is actually this year. So this actually allowed the government the time to reassess the market and to allow the industry to come up with new and more efficient power and cooling solutions, right? So if you look at elsewhere in the world, similar moratorium was actually applied, for example, in Amsterdam, Netherlands, back in July 2019, due to the strains on the property market as well as a power network. So the ban was actually lifted after a year under conditions such as locating data center in specific zones with limits on power use and floor space. So what are the implications of the moratorium on new data center for the greater Southeast Asia, right? So I think one of the key so-called effects, right, is actually investors now need to question whether other Southeast Asian countries may be viable alternative for them, right? So for our ASEAN neighbors, so there's the opportunity to attract projects that might otherwise have located in Singapore, and that's already happening. So if we have pay attention to some of the latest development, right? So I think here in Indonesia, especially at Batam, right? So a lot of data center operators are now actually eyeing Batam as a new digital hotspots, and given the close proximity of the Batam to Singapore, right? So certainly that's going to sort of create a lot of competition, right? So for Singapore, there are actually a number of opportunity costs, right? I think that just highlighting the three. So one obviously is actually the investment loss today due to the moratorium. Second is actually the loss of job creation opportunity in the industry, as well as the reduction in the long run competitiveness for what is an increasingly critical service, right, in support of the digital economy. but that the moratorium can actually spur innovation within Singapore, the data center industry, right? Making Singapore a world leader in terms of compute density, energy use, and sustainability. I think Singapore is overall a small economy, right? So, but I think with the solution, innovative solution that we develop, right, in order to help enhance the sustainability of the data center industry, we can actually certainly collaborate with our ASEAN neighbors and then really actually sort of look into deploying this, right, across the Southeast Asia region as well as the greater APAC. So some of the latest development in Singapore actually includes the Singapore Green Plan 2030, which reaffirms the local commitment to greening the economy. So while the Singapore Green Plan 2030 does not actually specifically mention the data center, but there are actually strong commitments to providing green infrastructure and building, as well as new investment that are carbon and energy efficient. So I think that being the case, we are actually very confident, right, that in the coming years, right, there should be a lot of initiative as well efforts that will sort of serve to enhance the data center industry for Singapore and beyond. So the unlocking of the Singapore data center, is it actually inevitable? So I would think so, right? So Singapore has become highly competitive in the global data center. So it has actually become a very strong incentive to maintain this position. So clearly the current moratorium is a clear and present risk to local competitiveness, right? Furthermore, our global society has become increasingly the data reliant with explosive adoptions of advanced data collection and analytical capabilities. So in short, data centers have become an increasingly critical infrastructure supporting the digital economy. So it's not so much a question of whether the moratorium will be lifted, but one around the timing and the condition for it to happen. So that's why I think the research community as well as the industry are actually kind of gearing up, right, for the opening, right? We're actually preparing ourselves. We're actually kind of trying to future-proof the data center industry here in Singapore. So what are some of the measures, right, that we can help make the data center industry more sustainable? As clearly, technology will be the critical determinant, right, for the resumption of growth for Singapore data center industry and beyond. Okay, so some of the solutions or innovative technologies and solutions that we can look forward to, including like co-energy based data center technology, underground data center or the data bunkers, underwater data center or seawater data center, as well as circular data center. So on the right, I've actually included pictures, which is kind of like a proof of concept by Microsoft, right? So basically, they actually immerse the data centers under the seabed, right? And they've shown that, in fact, the servers hardware actually operate more reliably, right? So the close at home, I think, were recently the NUS, together with a number of industry partners, right? We are actually now looking at harvesting the free coal energy from LNG regasification process, right? In order to not only improve the efficiency, the energy consumption, but certainly also the carbon footprint of data centers. But at the same time, regulations and standards play an important role, and may either force adoption of the right technology or sustain the inefficiency by locking in older or inefficient technology. So next slide, I'll actually provide a quick kind of snapshot of what are some of the possible pathways to achieving or greening your data centers, right? So including like integration with renewables. I think in Singapore context, very much just solar, right? Because we have very low wind speed. So that's why, for example, the wind energy is actually not viable, at least in Singapore context. But I think solar is actually something that the Singapore government is actually really pushing hard, right, in order to increase the deployment. Second is actually hydrogen, right, which actually represent a cleaner alternative fuel, especially for data center backup power, right, especially in the forms of fuel cell. But I think that will still require quite a number of years of R&D demonstration before it's actually ready for commercial deployment. But I think certainly we're very keen to work with various technology partners, right, to actually co-develop and demonstrate such solutions. The other being energy efficient cooling technology, which we think among the list is actually the most ready, because there are a lot of wonderful solutions out there. It's really more about appropriate engineering, right? So the sort of identifying the right type of cooling solution, right, as of in view of the local site condition and constraint, right? I think that alone can lead to a significant improvement in terms of PUE, in terms of the power consumption, as well as the associated carbon footprint reduction. So I think I've just now mentioned about free cool energy from LNG regasification. So NUS, we are actually working with a number of industry partners to actually do a demonstration of this concept. So the other is actually utilizing of seawater, I think especially in Southeast Asia. So a lot of our so-called fellow ASEAN neighbors are actually surrounded by seawater. So can we actually make use of seawater to further enhance the efficiency of the cooling system, right? And the other the positive effect is actually instead of discharging the waste into ambient air, you can actually sort of discharge it in seawater, thereby actually mitigating the urban heat island effect. So I think underground location I've already mentioned. Then I think there are other solutions pertaining to, for example, the more on the IT infrastructure innovation, as well as the AI machine and learning smart control. Okay, so the last one of those I just quickly run through what I've done, right? So I together with my startup Coolers TC, we are currently doing a test bedding of our high performance / efficiency, the liquid cooling solution at a co-location site, right? So this is actually the implementation. So I think the figure on the left actually shows the performance compared to the competing technology. But in the interest, I wouldn't go into the details. Yeah, so these are actually the two racks that we're actually test bedding at the co-location. So I have to stress it's a production data center site, because I think again, a lot of researchers are actually comfortable in doing lab-based work, right? Or lab-based research. But I think to really demonstrate that the technology is ready, you have to actually work closely with industry partner and really do the field testing, right, in order to demonstrate the readiness as well as the actual field performance that the various solutions can achieve. Yeah, so this is actually what we're currently doing at a major co-location site. So some of the things that I also want to highlight is actually beyond sort of saying, okay, I want to look into sort of a more sustainable or efficient data center power or cooling solution. I think we also have to recognize that in fact, power and cooling can be covered, right? So I think from our latest test bedding result, we've shown that if you were to deploy a very high performance liquid cooling solution, in fact, you can significantly slash the IT power consumption, right? Because associated with the use of very high performance liquid cooling solution, you can greatly reduce the junction temperature of your chips, right? And in doing so, your chip or your server power consumption is going to drop very significantly. In the latest test run, we have actually shown that even just at 60% loading, we are able to slash the total rack power consumption up to 29%, right? So this is over and above the improvement in terms of a PUE as well as your cooling system energy consumption, right? So obviously, all in all, that actually serves to significantly reduce the total power consumption for a data center. And that's obviously going to translate to a significant reduction in your carbon footprint. So the other initiative that I'm actually spearheading is actually this Sustainable Tropical Data Center testbed, which is actually co-funded by our National Research Foundation and Facebook to the tune of about $23 million. So this testbed is really to allow us to do the de-risking of innovative and sustainable data center cooling and power solution. And I want to stress, I think this is only possible if research performance actually work closely with industry partners, right? So we're actually we are going to likely operate using a consortium approach whereby we actually co-develop, demonstrate, and de-risk various sustainable cooling and power solutions together with industry partners, right? And to demonstrate that such new solutions actually have minimal risk or risk that can be managed, right? So as to convince them to take the next step, right, in terms of the actual deployment in production data center. Yeah. So I think in closing, so I basically want to say that Singapore actually has a very competitive data center industry because of the many advantages, the condition in spite of its punishing tropical climate, right, which is experienced by our ASEAN neighbors as well. So we have kind of moved from being one of the global market leader to the more tolerant. So obviously, I think that actually led to a lot of rethinking, reimagining what can we do in order to better sustain our DC industry. So currently, the carbon footprint of data center industry is certainly actually on the high side. So much so that the government actually felt compelled to limit a new data center in this high growth industry. So moving forward, what can we do? I think certainly we should move towards green data center. And as I mentioned just now, technology will be the critical determinant to the assumption of the growth of Singapore data center industry, and cooling being a major focus for research efforts. And the data center ecosystem contribution to the national progress, or even to the regional progress, right? If we look at Southeast Asia as a whole, must not be understated, right? So a delicate balance between economic growth and environmental concern must be achieved. Yeah, and I think that's only possible if we adopt a collaborative approach. So meaning that solution vendors, research performers, industry practitioners, as well as the regulators have to come together so that we actually openly discuss what are some of the associated issues, how do we sort of align our interests so as to steer the whole industry towards the green data center direction. So with that, I end my conclusion, or my presentation rather. Okay, thank you.
Thank you very much, Professor Lee. Okay, so that is then the closing for the insights regarding the panel discussion that we had. And meanwhile, several questions popped up in the chat box, which we have compiled, the organization committee has compiled meanwhile. So for the flow of the agenda, I just would like to inform you, we have scheduled this webinar until 11:45 Jakarta time, waktu Indonesia Barat. Yeah, so meaning we have like 15 more minutes to go. And these 15 more minutes, we would like to address a few of the questions. However, we will compile all questions and also share with the audience after this webinar as a follow-up together with the material. So don't worry, questions will not be lost anyway. And we close the webinar with the closing remarks of each panelist, just 2-3 sentences, and that will be the ending then on time, so that everybody can go to lunch at least according Indonesian time. So I see in the questions mainly now we have concerns regarding one hand is the technology, one hand, the other hand is then the economics, the economic side. So question regarding return on investment when we talk about absorption chillers. This is a question that I would like to address to Mr. Lewis in the beginning now. I've tried to summarize 2 questions to make it brief. So then we have this question coming from Patito. How is the financial analytical to get all the benefits efficiently regarding the absorption chillers and the CCHP systems impact to the ROI? Is there any rule of thumb, Louis, that you can give us in terms of the ROI calculation?
Thank you, Niels. Well, for the ROI, it would be a bit challenging at this moment, since you need to consider every single country prices in electricity, gas, the particularities of the location of the data center. Also for the CCHP, the power generation equipment will be, let's say, the main contributor of the CapEx. But I can say regarding the absorption chillers, the price would be similar to those mechanical chillers that are used in a traditional design. So Johnson Controls being a chiller OEM, I can focus on the cooling side of the CCHP plant, and absorption chillers are not more expensive than a more traditional mechanical chiller. For a detailed ROI calculation, we need to look into the electricity price, gas price of the particular location in Indonesia, and then see if the power generation equipment is a gas engine, is a gas turbine, is a fuel cell, what are the fuel that is driven this power generation equipment. So I would be no so keen to give a ROI number at this moment. But
okay, understand, Louis. Yeah, thanks. Anyway, the ROI calculation is for sure depending on many variables.
Exactly.
But is it? Can we conclude in general that we are not talking about the technology which is like doubling the capex of a data center, or like we're talking about 20 years plus ROI. I think that is what we can conclude.
No, yeah, exactly. And as I said at the beginning of the presentation, CCHP might be new for data center operators, but definitely is not a new technology. There are many industries and applications where CCHP is the core utility provider in terms of power, heating, cooling. So yeah, it's the ROI of those opportunities are compelling.
Okay, thank you very much, Luis. When we talk about the CCHP solution and this power supply actually of a data center, there is also a question or indicated in some questions, then we are focusing now on the power supply itself, and let's keep the focus on the power supply first of all, how to reduce the PUE value, meaning how to reduce the power supply. But another aspect is also then redundancy, safety aspects, how to keep the operational hours high, and erection time. And in that aspect, I would like to ask Mr. Ravindra, so for this solution that you have presented then, is like what is the impact on erection time and availability for data center provider?
Yeah, thanks, Nils. So our solution is a completely modular solution, and as is shown in the case study in Dublin, where we have installed 14 megawatt plant in just 14 or 12 to 14 weeks of time. That's a actual execution time at site. Of course, there is a planning and drawings and designs, which obviously took some time before that. But if we can plan it well in advance, the actual execution time is very, very less. We are talking about 3-4 months for making sure that a 10-15 megawatt power plant can be up and running. And because it's completely modular, we can keep adding the modules as and when it is required. So because for data center operators, they may not be sure that how much power is required on day one and how the business is expanding. They need to add the power according to that, or they want that power that quickly, depending on their business model. So I think our approach is in the same line. We can add up or remove the packs as and when it is required, and it can be done in a couple of months time. So it is not, we are not talking about years, we are talking about just a couple of months to deploy the solution.
Okay,
and
thank you.
Just to add on to the point or the earlier question which Louise had also answered, yes, CHP is a solution which we have also deployed for many other applications. So this is not something new. Probably for data center, it might be a little new, but we have got plants running across the globe which are deploying gas engines along with CHP.
Okay, thank you very much. Yeah, so we understand this solution, which is indeed a huge impact on the carbon footprint of a data center. Yeah, so we saw calculation between 40 up to 50% CO2 emission reduction just by implementing a state-of-the-art technology. That is indeed something that need to be discussed among the other solutions. I see also Professor Lee is already answering email questions in the chat box regarding immersion cooling. Thank you very much. Yeah, so we will keep it then in a written form. Another question coming up, also interesting, is then now when we talk about the power supply, but compared to that, the structure, the civil works, the structure of a data center. I guess this question can be addressed to Professor Lee first of all. That is, for the data centers, is there any strategy related to design, architectural or civil aspects, maybe related to room volume or facade design, to also come with another approach in the end, to achieve a greener data center? Professor Lewis, address to you first of all. Sorry, Professor Lee.
Okay, sure. Okay. Yeah. So, okay, first I have to profess that I'm actually more of a researcher. So I actually look at, for example, the development of the direct ship liquid cooling. So I have very little experience kind of designing the whole data center. But based on my understanding, right, I think it has to be appropriately engineered. right, based on the local site conditions and constraints, as well as the targets that the owners hope to achieve, right? So I think maybe to give an example, right? So if let's suppose you actually co-located, right, to an industry that have a source of waste heat, good quality waste heat, then certainly I think going with, for example, a cold generation of power and cooling, that may make sense, or even thermally driven cooling system, that may make sense. Or in the context, for example, if you can co-locate your data center next to an LNG terminal, right, where there's this source of free cold energy, right, due to the regasification process, then in that case, I suppose the tapping on this good flow, the seawater at the low temperature, certainly that's actually the way to go, right? But then obviously, if you're actually operating in another part of the world where the outdoor conditions is favorable, then using the free cooling, that certainly should be considered. But I think obviously our context is actually more Southeast Asia, which is hot and humid climatic condition, both in terms of obviously high temperature, ambient temperature, and high ambient humidity. So but I think I'm kind of biased because I work on direct chip liquid cooling. So I think going the liquid cooling, right, the big direct chip or immersion cooling is certainly the way to go. And it's actually well beyond just PUE or just the reduction in the cooling system energy consumption. So I think moving forward, we really need to take a more holistic approach, right? So meaning that there can be the coupling between power and cooling, as I've demonstrated, right? So once you greatly reduce the junction temperature of your chips, right, then you also get this side benefit, which in fact can be more significant than your PUE reduction, right, which you have demonstrated that, right? So for example, you're using the GPU intensive server. So in terms of the power consumption for server, it can be as high as 40 or even 50%. Right? So added together, obviously, then you're looking at a very significant reduction in the total power consumption. But I think this is only possible if solution vendors, data center operators actually work closely together. If you look at the current business model, right, especially colo operators, so they usually don't involve themselves in the decision on what kind of IT hardware to use. But moving forward, if we are actually serious about sustainability, I think it has to be a collaborative approach, whereby data center operators also actively involve themselves in the decision on both the IT hardware, the power, and the cooling, right? So that as a whole, you can actually achieve the best possible green data center.
Okay. Thank you, Professor Lee. Then we take this as the answer, and the holistic picture and the holistic approach for sure is important. So let me close the question and answer session, the verbal question answer session, with one more question addressed to Toto, and that is the question regarding the positioning of a data center. So as a provider, as an investor, and the founder of a data center, like to what extent does the data center tenants and such as in co-location case, whether and what extent do they consider green and energy efficiency features into their key factors to select the location of a data center? For example, we had this example with the LNG terminal. Sorry, no. Please.
Yeah. Okay, Neil. Well, that is an interesting question. If we segregate the data center customer market segment just simply into two categories, one is the hyperscaler, the other one is the retail customer, which is the size is much smaller, like financial services and other things. They do have a different priority, right? So the hyperscaler, we categorize under hyperscaler are the first, the cloud provider, second, the content providers, right? So cloud provider like AWS, Google Cloud, Microsoft Azure, Ali Cloud, and then the second tier will be Tencent and other second tier cloud provider. Content providers, a company like Facebook and other things. So those hyperscalers, they are very concerned about green data center. So they keep continuously pressurize the data center colocation provider of lowering the PUE and supporting them as well on how to get into their own targets into the zero carbon footprint. So those big clients has declared their commitment by 2030 to become zero carbon footprint. So the data center colocation provider has to play along with that for sure. While the small customers, the awareness of green data center still low. They are more concerned on the redundancy and everything, including the certification and everything. That is contradicting into the target of the lower PUE as well, green data center, right? So this is where the current situation is. So it's really up to our choice as a data center colocation provider. Do we want to concentrate on the hyperscaler, or do we want to concentrate on the retail market? So we can categorize in the future. There are two different market segments of data center. One is so-called hyperscale data center, and the second one is low latency data center, which the location will be in town, close proximity where the consumers are, right? And for sure, the size should not be big, but in-town data center will be, for them will be very challenging to construct the green data center over there, while the limited space as well, the supply of the power and everything. But their priority will be the low latency requirement for this. Yeah. Okay. So that's my view on it. Yeah.
Yeah. Thank you very much, Pak Toto. Would you like to add one more sentence regarding the closing remark? Do you have to add anything to just give as a key message to the audience before the close?
Well, my key message, my message will be like, yes, we have to support the green data center in balance, like Professor Lee said, with the economic itself, right? And how to mitigate around that. But we believe we should be very concerned about the environment, and every player has to do something over there, whether through efficiency of the cooling systems and or through the other way. But I'm very optimistic that Indonesia can move into green data center in a period of time.
Okay, thank you very much for this positive outview, Pak Toto. So then I hand over to Mr. Ravindra. Would you like to add the key message from your side?
Yeah, I think sustainable data center is the requirement, not because customer is asking for it. Yes, definitely that's the important point. But it is for our own generation and for our future generation. We have to make sure that we are using everything more sustainably. And I think gas-based power plant or gas-based generation, including the renewables, will be the key thing to look at for greener data centers in Indonesia. Thank you. Thank you.
Okay, thanks, Mr. Ravindra. And Luis, your key message coming from Madrid.
Okay, I would say combined power and cooling is a proven and mature technology that maximizes the efficiency. It helps data center operator to reduce significantly the chill water plant consumption, and therefore it will reduce the PUE of the overall data center.
Clear and understandable. Thank you, Luis. So let's close remarks with Professor Lee from Singapore. The key message from your side, please.
Okay, sure. Yeah, so I just like to highlight the need to adopt a collaborative approach, right, when it comes to sustainability, as well as the need to have the holistic mindset, right? So it's not just one single piece of a solution, but really the integration of, for example, renewable coupled with energy efficiency technology, yeah, as well as probably the associated business model, yeah, because I think it's only sustainable if it's commercially viable.
Okay, that is also fair enough. Thank you very much, Professor Lee. Yeah, so with having said that, it is time to close this webinar, first one of its kind there for Indonesia. I think we can conclude that this it has given very useful insights, and thanks again very much, first of all, to the speakers, to the panelists, giving us the opportunity to listen to these insights, and to IDPRO, MASKEEI organization, to realize this webinar. And for sure, also, I would like to thank the organization committee led by Dian Lestari, my wonderful colleague, who organized behind the scene this webinar, which went quite fluently. And thank you very much again for everybody. Have a good day ahead, and sampai jumpa. Terima kasih.
Thank you. Bye.
Thank you.
Sampai jumpa. Thank you,
Sampai jumpa.
everyone.
Thank you.
Jumpa.
Terima kasih.
Terima kasih
Terima
semuanya.
kasih.
Stay healthy. Stay healthy.
Thank you.